Hello, I am Mayagüel Ortega Vilés, professor from the Instituto Politécnico Nacional, presenting the work Synthesis, Characterization, and Carbon Monoxide Sensing Properties of UNDOPED and copper-doped cobalt oxide films. The need for carbon monoxide monitoring in commercial aircraft motivated this work, proposing copper cobaltite as a cheap sensitive material for the detection of this gas. Carbon monoxide has a very high affinity for hemoglobin, the molecule in blood responsible to transporting oxygen through the body. Carbon monoxide attaches to the hemoglobin, creating the compound carboxyhemoglobin, which blocking oxygen transport. Continued exposure increases risk to pilots, including impaired judgment, and decreases ability to control the airplane and eventually incapacitation and death. On the other hand, the production of nanostructured semiconductor oxides by means of new preparation pathways increases sensitivity, increases selectivity, decreases response time, and stability of conductimetric gas sensor. The methodology used involves a series of stages that are observed in the diagram. The resulting films were characterized by CM, XRD, TM, and Raman spectroscopy, and sensitivity tests were performed. The results obtained by CM show the elongated crystalline grooves are formed with a tip ending in the shape of a four-sided pyramid with an average length of 53 nanometers that, when heat treatment is applied, become rounded and the crystal being to join. After the sonochemical process occurs, an obvious modification and the gaps between the crystals allow greater contact with the target gas. The XRD results indicate that the sputtered film with heat treatment was transformed into pure cobalt oxide with cubic structure. In addition, it was determined that the sonochemical process promotes the substitution of cobalt plus 2 ions for copper plus 2 ions in the spinel-like structure of cobalt oxide, forming non-stoichiometric copper cobaltite before heat treatment to get stoichiometric copper cobaltite, which confirmed the evolution of cobalt oxide to copper cobaltite during the two-step synthesis process. On the other hand, the TM analysis reveals that the films have a polycrystalline nature, as can be seen in the electron diffraction pattern, and they are composed of nanoparticles with an average size of 5 nanometers. The high-resolution TM image shows interplanar spacing of 1.23 angstroms, corresponding to the D spacing of the 533 planes of copper cobaltite. The Raman spectroscopy was also used to study the vibrational modes and structural changes. All samples show 5 prominent peaks with different symmetries, as can be appreciated in the spectra. The peak located at 196 wave numbers owed to the representative tetrahedral sites with copper ions, and the peaks at 692 wave numbers belong to the representative octahedral sites with cobalt ions. No additional peaks were observed, indicating purity of copper cobaltite spinel. Finally, the copper cobaltite shows an improvement in carbon monoxide detection because it presents more active sites than cobalt oxide by the different balances of both metals, copper plus 1, copper plus 2, cobalt plus 2, and cobalt plus 3, which favors the oxidation of carbon monoxide. The response and recovery times at 200 Celsius and 100 cubic centimeters of carbon monoxide from M1 and M2 samples were 134 seconds respectively. From the result, it's concluded that the polycrystalline undoped and copper-doped cobalt oxide thin films were successfully deposited by two-step method that combine reactive sputtering and sonochemical processes. The sonochemical process applied to cobalt oxide films promoted the replacement of cobalt plus 2 ions by copper plus 2 ions under appropriate pH conditions, which was confirmed by X-ray diffraction analysis. The characterization results are in good accordance with the structural evolution of the films during the preparation pathway. Only the film with 7 millimoles of copper ions presented response at 100 Celsius before to reach the standard of 50 ppm established by Federal Aviation Administration in the cabin for an aircraft. The response and recovery times at 200 Celsius are too similar for M2 and M1, even if a better signal was obtained in M2 after ionic exchange in the spinel crystalline structure. From the results obtained in this work, it can be discerned that copper cobaltite films are potentially applicable for carbon monoxide gas sensors. Thank you very much for your attention.